Welcome to aminacademy.com. We will go mini 2 on mathematics. Mathematics is an area of knowledge that includes the topics of numbers, formulas and related structures, shapes and the spaces in which they are contained, and quantities and their changes. Really, the mathematics is a vast area. It is a very small definition on it. The main branch of mathematics are algebra, number theory and geometry and arithmetics. A number is a mathematical object used to count, measure and label. The original examples are the natural numbers. Normally you are using 1, 2, 3, 4, 5, 6, 7 up to infinity. Here the numbers are represented in symbols. Here there are a lot of numeral systems are there, but normally we are using 0, 1, 2, 3 is a Indo-Arabian numerical system. Here is a number system. These are some numeral systems in the world, but mostly we are using Indo-Arabian systems like 0, 1, 2, 3, 4, like natural numbers. Natural numbers are known as counting numbers that contain the positive integers from 1 to infinity. The set of natural numbers is denoted by n. Look here, if we add 0 with this natural number, it becomes a whole number, set of whole numbers. Integers. Integers are the set of all whole numbers, but it includes a negative set of natural numbers also. It denotes by z. Suppose if we are adding negative numbers with positive numbers, it indicates integers. Real numbers. All the positive and negative integers, fractional and decimal numbers without imaginary numbers are called real numbers. All numbers are real numbers except the imaginary numbers. Rational numbers. Any number that can be written as a ratio of one number over another number is written as rational numbers. This means that any numbers that can be written in the form of p over q is called rational numbers. Q equal to p over q. Here this is a rational numbers. For examples, like here half, 5 by 3, 60, 0.365, like these are the rational numbers. Next, irrational number, the opposite of rational number. That is, the numbers that cannot be expressed as the ratio of one over another is known as irrational numbers, and it is represented by the symbols p. Look at this irrational number, square root of 2. Suppose we are expressing this number as decimal, it won't end. That means even this pattern will not repeat. That is, square root of 2 is 1.412, like it's go on increasing, but never end as well as never repeat the pattern. Pi is a very good example for this irrational number. Complex number, the number that can be written in the form of a plus bi, where a and b are the real numbers and I is an imaginary number, is known as complex number C. Here that means here I squared equal to minus 1 is the basic for the complex number. That means I is square root of minus 1. Square root of minus 1 indicates imaginary, that is imaginary part of that number. Means normally square root of minus number is not a real number, it's an imaginary number. Imaginary and real combined together is a complex number. Look at this complex number structure. Z equal to a plus ib. This is a real part, it's an imaginary part. Imaginary numbers are the complex numbers that can be written in the form of a product of real numbers and the imaginary unit I. Without algebra, there is no mathematics. Algebra is a queen of mathematics. It is a branch of mathematics in which arithmetic operation and other formal manipulations are applied to abstract symbols rather than specific numbers. Algebra, from Arabic aljabar, reunion of broken parts, that is, bone setting, is the study of variables and the rules of manipulating these variables in formulas. It is a unifying thread of almost all of the mathematics. Elementary mathematics deals with the manipulation of variables, that is commonly represented by Roman letters, as if they were numbers, and is therefore essential in all application of mathematics. Abstract algebra is the name given mostly in education to the study of algebraic structures such as groups, rings and fields. Linear algebra, which deals with the linear equation and linear mapping, is used for modern presentation of geometry and has many practical applications like weather forecasting. There are many areas of mathematics that belong to the algebra, some having algebra in their name. Here, algebra over a field, Boolean algebra are the part of that algebra. Branches of algebra. Elementary algebra covers the traditional topic studies in a modern elementary algebra course. Arithmetic includes numbers along with mathematical operations like addition, subtraction, multiplication, division. But in algebra, the numbers are often represented by the symbols and are called variables such as x, y, z, like. It also allows the common formulation of the laws of arithmetic such as a plus b equals b plus a, like commutative, and addition, multiplication, subtraction, anything can be done here. Advanced algebra. This is the intermediate level of algebra. This algebra has a high level of equations to solve as compared to pre-algebra. Advanced algebra will help you to go through the other parts of the algebra such as equation and with inequalities, matrices, solving system of linear equations, graphing, conic sections, polynomial equations, quadratic equation and functions, sequence and series, rational numbers, trigonometry, discrete mathematics, probability, etc. all inclusive algebra. Abstract algebra is one of the divisions in algebra which discovers the truths relating to algebraic system independent of the specific nature of some operations. These operations in specific cases have certain properties. Thus, we can conclude some consequences of such properties. Hence, this branch of mathematics called abstract algebra. It includes set theory, binary operation, identity elements, inverse elements, associativity. Linear algebra is a branch of algebra that applies to both applied as well as pure mathematics. It deals with the linear mapping between the vector spaces. It also deals with the study of planes and lines. It is study of linear sets of equations with transformation properties. It includes linear equations, vector spaces, relations, matrices and matrix decomposition, relation and computations. Commutative algebra is one of the branch of algebra that studies the commutative rings and their ideals. Algebraic equation, statement of the equality of two expressions formulated by applying to a set of variables with algebraic operations, namely addition, subtraction, multiplication, division, raising to powers and extraction of rows. For example, here x cube equal to x cube plus 1 and x y power 4 x squared plus 2xy minus y divided by x minus 1 equal to 2. These are the some examples equations. Here, this a quadratic equation. Very basic structure of quadratic equation is ax square plus bx plus c, where a should not be 0. Here, algebraic formulas or identities. Suppose here binomial expression said a plus b whole square equal to a square plus 2ab plus b square. Everybody knows. Like this, lot of expression we can do with algebraic formulas. Types of algebraic equation. Algebraic equations, questions are solved based on their position of variables, their function and the types of operations used. A few of the equations algebra are discussed here. Now, linear equation is ax plus b equal to c. We can solve the value of x here. Next is a quadratic equation. This basic function is f of x equal to ax square plus bx plus c, which is equal to 0. It's called a quadratic equation. Then we can use quadratic formula and factorizing. We can solve this. Quadratic equation symbol is ax square plus bx plus c equal to 0, where a should not be 0 here. A, b, c are constant, x is variable here. Cubic equations also can be solved with proper steps. Trigonometry, the branch of mathematics concerned with specific functions of angles and their application to calculation. There are 6 functions of an angle commonly used in the trigonometry. Their names and abbreviations are sine, cosine, tangent, cotangent, secant and cosecant. Here, in a right triangle, opposite side is here, adjacent is base, and this is a opposite to right angle is 90 degrees hypotenuse. Here the 6 ratios are there. For example, here sine is opposite by hypotenuse, cos is adjacent by hypotenuse, and tan is opposite by adjacent. Then reciprocal of them is another 3 ratios. History of trigonometry. The word trigonometry comes from the Greek word trigonon, that is a triangle, and metron, that is to measure. Until about 16th century, trigonometry was chiefly concerned with computing the numerical values of the missing part of a triangle or any shape that can be dissected into the triangle. Here, for trigonometry, the Pythagorean theorem is very important. From the base of the Pythagorean theorem, the trigonometry is developed. Ancient Egypt and the Mediterranean world, several ancient civilizations, in particularly Egyptian and Babylonian, Hindu and Chinese, possessed a considerable knowledge of practical geometry. A close analysis of the text with its accompanying figure reveals that this word means the slope of an incline, essential knowledge of huge construction projects such as the pyramids. The trigonometry is the base knowledge of constructing big pyramids. Triangle inscribed in a circle. Trigonometry in the modern sense began with the Greeks. Hipparchus was the first to construct a table of value for trigonometric functions. He considered every triangle, planar or spherical, as being inscribed in a circle so that each side becomes a chord, that is a straight line that connects 2 points on a curve or a surface, as shown in the inscribed triangle in a circle. As an astronomer, Hipparchus was mainly interested in the spherical triangles, such as the imaginary triangle formed by 3 stars on the celestial sphere. But he was also familiar with the basic formulas of plane trigonometry also. Here the basic trigonometric formulas are sin squared plus cos squared equal to 1. That is sin squared A plus cos squared A equal to 1. From that another formulas also derived. Tan squared plus 1 is secant squared. 1 plus cot squared equal to secant squared. Like this, lot of identities can be proved. Double angle formula is there here. Also, sine for law of sines is there, law of cosine is there. Lot of identities you can derive from the base of the sin squared plus cos, sin squared A plus cos squared equal to 1. The next major contribution to trigonometry came from India, and the sexagesimal system, multiplication of or division by 120, that is twice 60, is analogous to multiplication or division by 20, that is twice 10 in the decimal system. Here normally suppose sin A or sin B equal to C over 120, that is where B equal to A by 2 like. That means from this basic ratios, basic functions, we can show it's in the ratio. Suppose sin 30 is 1 by 2, cos 30 is 1 by, sin 45 is 1 by root 2, tan sin 90 is 1, like we can derive the ratios of the basic trigonometric functions. While Europe was plunged into darkness, the torch of learning was kept alive by Arab and Jewish scholars living in Spain, Mesopotamia and Persia. The first table of tangents and cotangents was constructed around 860 by Habash al-Hasib, that means the calculator, who wrote on astronomy and astronomical instruments. Another Arab astronomer, al-Bathani, gave a rule for finding the elevation theta of the sun above the horizon in terms of the length S of the shadow cast by vertical gnomon of height h. Until 16th century, it was chiefly spherical trigonometry that interested scholars, a consequence of the predominance of astronomy among the natural sciences. The first definition of a spherical triangle is contained in Book of Spherica. Several Arab scholars, notably Nasir al-Din al-Tusi and al-Battani, continued to develop spherical trigonometry and brought it to its present form. The final major development in classical trigonometry was the invention of logarithms by Scottish mathematician John Napier in 1614. This table of logarithms greatly facilitated the art of numerical computation, including the compilation of trigonometry tables, and were hailed as one of the greatest contributions to the science. From geometric to analytic trigonometry. In the 16th century, trigonometry began to change its character from a purely geometric discipline to an algebraic analytic subject. Now, the trigonometric ratio also can be expressed in the power series for trigonometric functions, like suppose sin x can be expressed as x minus x cubed by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial. Like that, other ratios also expressed as a power ratios, power series. Trigonometry to application to the science. While these developments shifted trigonometry away from its original connection to triangles, the practical aspects of the subjects were not neglected. In 17th and 18th centuries saw the invention of numerous mechanical devices, from accurate clocks and navigational tools to musical instruments of superior quality and greater tonal range, all of which required at least some knowledge of trigonometry. A notable application was the science of artillery, and in the 18th century it was a science. Galileo Galilei discovered that any motion such as that of a projectile under the force of gravity can be resolved into two components, one horizontal and one another vertical, and that these components can be treated independently of one another. This discovery led scientists to the formula for the range of cannonball when its muzzle velocity is given. Another practical aspect of trigonometry that received a great deal of attention during this time period was surveying. Trigonometric functions. A somewhat more general concept of angle is required for trigonometry than for geometry. An angle is here, which is formed by two straight lines meet at one point and goes continuously. The two lines go away, that is not a parallel. Look at this. In xy axis, trigonometric functions can be dealt like here the point Q can be represented, that is here, which from the x-axis is y distance, and from origin and the y-axis parallel to y-axis is x distance. That means here this is the angle between them. These 6 ratios can be expressed in this triangle. That is, suppose if sine A, the sine of the triangle is what? Opposite by hypotenuse, y by r. Here cos A equal to x by r. Like any angle can be represented in terms of trigonometric ratios. That means what? From the origin to join that point, and the ratios of these 3 sides can be expressed in terms of angles and its ratios. Here, common angles for trigonometric function is more useful. This table can be created by, if you understand one angles known. That means sine angles of all 0, 30 degree, 45 degree, 60 degree and 90 degrees given. We can get it other ratios also. Spherical trigonometry involves the study of spherical triangles which are formed by the intersection of 3 great circle arcs on the surface of sphere. Spherical triangles were subject to intense study from antiquity because of their usefulness in navigation, cartography and astronomy. Here, half angle formula is expressed in terms of other ratios. Analytic trigonometry combines the use of coordinate system such as the Cartesian coordinate system used in analytic geometry with algebraic manipulation of various trigonometric functions to obtain formulas useful for the scientific and engineering applications. Here the graph for sine, cos, tan and cot is given like these are continuous functions, like sine and cos is continuous. In calculus, it is shown that sin x and cos x are sums of the powers of power series. Coordinate and transformation of coordinates. Here, this is Cartesian coordinates can be transformed to polar coordinates like here. Any point P is on the xy axis, xy plane. Then we can say for problem involving the direction from the fixed origin or a pole, O is a pole here, it is often convenient to specify the point P by its polar coordinates r and theta. Here x and y is a Cartesian coordinate, r and theta is a polar coordinate system. A transformation of coordinates in a plane in a change from one coordinate system to another is possible by using this rule. Euclidean geometry is a mathematical system attributed to ancient Greek mathematician Euclid, which he described in his textbook on geometry, that is elements. Euclid's approach consists in assuming a small set of intuitively appealing axioms, that is postulates, and deducing many other propositions, theorems from these. The elements that this book he has written begins with plane geometry, still taught in secondary schools, in high schools as the first axiomatic system and the first examples of mathematical proofs. It goes on to the solid geometry of 3 dimensions. Much of the elements states results of what are now called algebra and number theory explained in geometrical language. Main article in Euclid's Elements. The elements in mainly a systemization of earlier knowledge of geometry. Its improvement over earlier treatment was rapidly recognized, with the result that there was little interest in preserving the earlier ones, and they are now nearly all lost. Euclidean geometry is an axiomatic system in which all theorems, that is true statement, are derived from a small number of simple axioms. Until the advent of non-Euclidean geometry, these axioms were considered to be obviously true in the physical world, so that all the theorems would be equally true. Euclids have 5 postulates. First one, to draw straight lines from any point to any point. Second one, to extend a finite straight line continuously in a straight line. To describe a circle with any center and distance, that is radius, that all right angles are equal to one another. Fifth one, parallel postulates, that if a straight line falling on 2 straight lines make the interior angles of the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on the side on which the angles are less than 2 right angles. Euclid geometry is a constructive postulates, 5 postulates assert that existence and uniqueness of certain geometric figures, and these assertions are of a constructive nature, that if we are not only told that certain things exist but are Also given methods of creating them with no more than a compass and an unmarked straight edges. The Pythagorean theorem states that the sum of the areas of the two squares on the legs A and B of a right triangle equals the area of the square on the hypotenuse. Like this area is equal to sum of these areas A and B. He explained the Thales theorem in these elements. Thales theorem states that AC is the diameter. In this figure, AC is the diameter. Then the angle at B is right angles. Here he explained in the congruence triangles also. That means these two triangles are everywhere equal. That means all respective sides are equal, respective angles are equal. Congruence of a triangle is determined by specifying two sides and the angle between them, that is SAS, two angles and the side between them, ASA, or two angles and a corresponding adjacent sides, AAS. Specifying two sides of an adjacent angles, SSA, however, can yield two distinct possible triangles unless the angle specified is a right angle. Triangle angle sum. The sum of the angles of the triangle is equal to straight angles, that is 180 degrees. This causes an equilateral triangle to have three interior angles of 60 degrees. Also, it causes every triangles to have at least two acute angles and up to one obtuse or right angle. Pythagorean theorems. Further, the celebrated Pythagorean theorem states that any right triangle, the area of the square whose side is the hypotenuse, that is side opposite to right angle, is equal to the sum of the areas of the squares whose sides are the two legs. That means the two sides that meet at a right angle. In 17th century, Descartes developed analytical geometry, an alternative method for formalizing geometry which focused on turning geometry into algebra. In this approach, a point on a plane is represented by its Cartesian xy coordinates and a line is represented by its equation and so on. In Euclid's original approach, the Pythagorean theorem follows from Euclid's axioms. Look at this figure here. This is a very interesting figure here. That is a circle is radius 1 unit. The side of the square is root of pi. Non-Euclidean geometry. The century's most influenced development is geometry occurred when around 1830, and in the 19th century it was also realized that Euclid's 10 axioms and common notions do not suffice to prove all of the theorems stated in the elements. For example, Euclid assumed implicitly that any line contains at least 2 points, but this assumption cannot be proved from the other axioms and therefore must be an axiom itself. Next we will discuss about Cartesian coordinate. René Descartes, born in March 31, 1596, French mathematician, scientist and philosopher, because he was one of the first and abundant scholastics Aristotelianism, because he formulated the first modern version of mind-body dualism, from which stems that mind-body problem, and because he promoted the development of a new science grounded in the observation and experiment. He is generally regarded as the founder of modern philosophy. Coordinates are a set of values which helps to show the exact position of the point in the coordinate plane. A coordinate plane is a 2D plane which is formed by the intersection of two perpendicular lines known as the x-axis and y-axis. This is the basic for coordinate system. What is coordinate geometry? Coordinate geometry is a part of geometry that uses two or more numbers to specify the position of any point, figures or object. The position of the object can be defined in a line or a plane or three-dimensional space and so on. Below are the types of coordinate system. This is a number line, Cartesian coordinate system, plane, three-dimensional plane and figures. Coordinate geometry in a plane will be particularly using the Cartesian coordinate system, a particular type among many which represent each point by using a pair of numbers, that is the coordinates, which are the assigned distances of the point from two fixed perpendicular lines known that axis. Here from coordinates geometry we can discuss about the distance between two points. That is, distance between the 2 points is that means AB square. Suppose points A and B, the distance square of the distance AB square equal to BX minus AX whole square plus BY minus AY whole square. That means that is AB equal to square root of these things. The midpoint is the points x1 plus x2 divided by 2, y1 plus y2 divided by 2. Gradient of a line joining 2 points. The gradient of the line joining 2 points of x1 and x1 y1, x2 y2 is y2 minus y1 over x2 minus x1. If two lines are perpendicular, the gradient product of the gradient is minus 1. The equation of the straight line is y minus y1 equal to m into x minus x1. What is 3D geometry? The 3D geometry helps in the representation of a line or a plane in a three-dimensional plane using the x-axis, y-axis and z-axis. The coordinate of any point in the three-dimensional geometry have three coordinates x, y, z. Geometry makes use of the three coordinates to represent points. The important concepts with reference of three-dimensional geometry are direction ratios, direction cosines, distance formula, midpoint formula and section formula. Here also in three-dimensional also distance formula we can represent like d equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square, z2 minus z1 whole square under the square root. Even midpoint formula also we can find, that is midpoint is x1 plus x2 plus x3 by 3. x1 like y1 plus y2 plus y3 by 3 plus comma z1 z2 plus z3 divided by 3. Like that we can find midpoint formula in three dimensional also. Joining the points, you can find the midpoint of the 3 points in that way. The equation of a line in three-dimensional Cartesian system can be computed from the following two methods. The two methods of finding the equation of a line are as follows. Here, that is r equal to a plus lambda b you can represent, or further the equation of a line passing through two given points, and a and b can be represented by r equal a plus lambda into b minus a, lambda b any constant. Calculus, a fantastic branch of mathematics. Calculus, the branch of mathematics concerned with the calculation of instantaneous rates of changes, that is differential calculus, and the summation of infinitely many small factors to determine some whole, that is integral calculus. Calculus is concerned with two basic operations, differentiation and integration, and is a tool used by engineers to determine such quantities as rate of change and areas. In fact, calculus is the mathematical backbone for dealing with problems where variables changes with time or some other reference variable like that. Calculus, the originally called infinitesimal calculus or the calculus of infinitesimals, is the mathematical study of continuous change in the same way that geometry is the study of shape and algebra is the study of generalization of arithmetic operations. It has two major branches, differential calculus and integral calculus. The former concerns the instantaneous rate of change and the slope of curves, while the latter concerns accumulation of quantities and areas under or between curves. These two branches are related to each other by the fundamental theorem of calculus, and they make use of the fundamental notions of convergence of infinite sequences and infinite series to a well-defined limit. Infinitesimal calculus was developed independently in the late 17th century by Isaac Newton and Gottfried Wilhelm Leibniz. Later work, including codifying the idea of limits, put these developments on a more solid conceptual footings. Today, calculus has widespread uses in science, engineering, and social sciences. The word calculus comes from Latin meaning small stone, because it is like understanding something by looking at small pieces. Differential calculus cuts something into small pieces to find how it changes. Integral calculus joins, that is, integrates the small pieces together to find how much there is. Limits are about approaching. Sometimes you can't work something out directly, but you can see what it should be as you get closer and closer. There are a lot of differential calculus formulas. Differentiation is the process of finding the derivatives of a function. The derivative of a function is defined as y equal to f of x of a variable x, which is the measure of the rate of change of a variable y changes with respect to the change of variable x. It means that the derivative of a function with respect to the variable x, there are some number of rules to find the derivative of a function. These are the derivative formulas. Still more formulas are there. the integral calculus formulas. The basic use of integration is to add the slices and make it into a whole thing. In other words, integration is the process of continuous addition, and the variable c represent the constant of integration. But often integration formulas are used to find the central points, areas and volumes of the most important things. Also, it helps to find the area under the curve of a function. There are certain important integral calculus formulas are here. Vedic mathematics is the name given to a supposedly ancient system of calculation which was rediscovered from the Vedas between 1911 to 1918 by Sri Bharati Krishna Tirthaji Maharaj. According to Tirthaji, all of Vedic mathematics is based on 16 sutras or word formulas. Probability is simply how likely something is to happen. However, whenever we are unsure about the outcome of an event, we can't talk about the probabilities of certain outcomes, how likely they are. The analysis of events governed by probability is called statistics. Normally you are speaking about probably it happened. Most probably I will come there. Like which means it happened. How possibly it happens is deals with the probability subject. Look at here. Here, suppose a die is thrown. If it is, there is no chance means there is no chance to give any number or expecting number. It's impossible event. If you have only 1 in 6 chances, we are getting unlikely. Even chances. If you are getting 3 out of 6 is even chances. More than 3, it is 4 in 5 is called likely. If you get all chances, it's called certain. Probability are very interesting subjects in precasting the things in future. In future, what happened to the business, something it's mostly related to statistics. Modern algebra, also called abstract algebra, branch of mathematics concerned with the general algebraic structure of various sets. In mathematics, most usually algebra, abstract algebra or modern algebra is the study of algebraic structures. Vectors in math are objects which have both magnitude and directions. It is called a vector of some things. Yeah, like suppose look at this line, it have the direction as well as the how much its length, it's a magnitude. Here lot of vectors are there, zero vectors, unit vectors, position vectors, like this, lot of vectors is there. Matrices is, in mathematics, a matrix, that plural of matrices, is a rectangular array of or table of numbers, symbols or expressions arranged in row and columns, which is used to represent the mathematical object or a property of such an object. Mathematics, that is matrices have a lot of subdivisions. It's more useful in linear algebra. The topology studies the property of spaces that are invariant under any continuous deformation. It is sometimes called rubber sheet geometry because the object can be stretched and contracted like rubber but cannot be broken. Without breaking, any object can be made with flexibility of rubber. It indicates the topological figures. you have done. Please subscribe our YouTube channel.